In AI data centers, not all real estate is equal. The physical space closest to AI GPUs, which demand lots of power and cooling, becomes especially valuable. Why? Because that space enables the infrastructure required to support AI. This graph represents the value of data center real estate, from the gray space to the AI server cabinet. To support AI performance, it's critical to shrink the footprint of power distribution as you get closer to AI servers. This frees up valuable space and enables AI data centers to operate at peak compute efficiency. Current power infrastructure in data centers typically supports between 3 kilowatts and 14 kilowatts per cabinet, primarily using 415-volt AC three-phase power. But that's not nearly enough power to support AI workloads, which are expected to demand between 25 and 200 kilowatts per cabinet in the next few years. This presents significant challenges for traditional power infrastructure. It's especially challenging for data center operators to add this level of power to existing facilities without disrupting operations and production, since the space above and between the racks is often packed with operating equipment. Moreover, for any power levels that exceed 25 kilowatts per cabinet, liquid cooling infrastructure is typically needed. Plus, when scaling to 100 kilowatts, you also must consider additional fiber infrastructure and liquid cooling systems. These considerations must be made close to the GPUs, where space is most valuable. In existing data centers, these additions can't be done without significant disruption and cost. The challenge doesn't end in the power distribution space. As you can see, when scaling to 100 kilowatts inside the server cabinet, data center operators will be met with the same crowding issues, which limits access to critical connections, restricts airflow, and makes changes exceptionally difficult. The size of the server cabinet PDUs to support 100 kilowatts in a single cabinet becomes impractical. We'll start by adding 100 kilowatts to a single cabinet in an existing data center using VoltServer's digital electricity. These solutions are made up of only 3 primary components: transmitters, pre-terminated digital electricity cable assemblies, and digital electricity server cabinet PDUs. This modularity makes adding power to your white space fast, simple, and non-disruptive. And it allows you to pay as you grow. With components in hand, starting at the gray space, you add a single transmitter rack using an existing UPS battery, or by including a rack-mounted UPS within the transmitter rack. The configured transmitter rack can deliver hundreds of kilowatts. Additionally, digital electricity can support multiple power types at the server cabinet. High voltage DC is the most efficient option, but lower power density options for AC and 48-volt DC are also available. This is the look of the deployment inside the server cabinet now, with 2 50-kilowatt server cabinet PDUs in an N+1 configuration. Because VoltServer's digital electricity is an intelligent system with multiple points to increase resiliency, you have the flexibility to easily design your power backup as you see fit. In this image, we're demonstrating 4 redundant transmitters feeding 2 digital electricity PDUs within a server cabinet. Here, we add a second 100 kilowatt cabinet in an existing data center using VoltServer's digital electricity. When you're ready to upgrade an entire row, you can leave busway in place or you can remove it. In this image, we remove the legacy busway, quickly evolving the entire data center with minimal disruption. Through our patented and proven technology, digital electricity can help AI data centers free up valuable space and operate at peak compute efficiency. For support on project design and product availability information, contact VoltServer today.